Hello everyone, my name is Go Kai-sen and I'm going to present our proposed system, which is Smart Classroom Monitoring System, and we are from Group 23. So let me have a quick introduction to my teammate. The first one is the Feng Si Wong, studying computer science. The second one is Go Kai-sen, which is me, studying computer science, and followed by Ho Chong-ling and Yong Xiyan, which also studying computer science. So let's have a look on our background of study first. Smart Classroom is an educational smart system. It has many examples such as interactive whiteboards, projectors, visualizers, and attendance system. And this smart classroom actually based on the IoT, Internet of Things, which is used to create the smart classroom system. It is a framework to integrate with devices such as sensors, cameras, and smartphones. And it has a lot of beneficial for sharing and analyzing data to improve the student concentration and increase their productivity in class. And all data will be stored in the cloud and can be viewed and accessed anytime and anywhere and shared to any device. That's all for my part here. I'll move to the next part. Thank you.
I am Yong Sui. Today I'm going to talk about the history and future trend of Smart Classroom Monitoring System. Initially, teachers will conduct Q&A sessions in class to help students to pay attention. In the early years of 1960, computer vision was introduced. Recently, it is used in school. Cameras were installed to monitor the students and track the student that is not paying attention. It will scan his face and store his record on the server. The teacher can view the records with their mobile, phone, or computer. In the past, the attendance of the students was manually recorded into the computer. It is not effective because it takes a long time to do it. Radio frequency identification base was invented in 1983, and recently it is used in universities and colleges. Biometric authentication and manual entry attendance software-based solutions are also used to automatically record and store the attendance records nowadays. Michel Hugon of Boo CP8 was the first to design a smart card that has a processor and local memory in March 1979. Recently, they are used to monitor the movement of students in school and limit their access in certain classrooms. It replaces the lock and key system. Machine learning should help a teacher to analyze the data in the cloud and automatically generate statistical data for better visualization. It will minimize the effort of the teachers to go through all the records because it will consume a lot of time. It also can be used to track the students' attendance record. It should predict which student is going to be absent and their reason to be absent. Voice recognition software should be added to monitor and manage the surroundings of the classroom, such as light brightness. It can only be controlled by the school teachers or school administrators. Another authentication method is to use smart card to control the settings.
Good day everyone, my name is Ho Chong-ling and I'm going to present the problem statement, objective and proposed solution of this project. Monitoring a classroom is always a challenge in the school management. This is because they might have students with the negative attitude which cause unpleasant learning environment and also disciplinary and behavioral problem. Besides, to resolve their new bad attitude problem is the main concern instead of stopping them, since these students will always try to come up with the new idea that break the school rules. And for experienced teachers, this will be a normal for them to handle it, but it is difficult for newbie teachers that lack of experience, and it might be a nightmare for teachers who are unable to handle this kind of situation. And the objective of this project is to improve the student learning and efficiency, yet to ensure their respective safety and to improve the parental confidence of school management, as the proposed solution is a smart classroom monitoring system where it is a system that developed to detect certain prohibited items such as phone, gaming console, knife, and etc. Will also act as a helper for the teacher in monitoring the classroom. And that's all for my part. I'll pass to the next presenter. Thank you.
Hi sir, now I will present about the architecture diagram of proposed solution part. The following diagram is the architecture diagram of our smart classroom monitoring system by using the Amazon Cloud Platform. AWS, we also call as Amazon Web Service, is a platform that provides the IT-related service to a business. Now I will explain about the usage and the flow of each service in our architecture diagram. The first one will be the IoT device such as camera that will be connected to the IoT core by using the private key and the certificate that register in the IoT core. After the IoT core have retrieved the image from the environment, it will send the image to the S3 bucket, and once the S3 has stored the image, it will send the image to the Lambda for progress with the help of the recognition. In this case, the targeted image will be the image of students that bring in the prohibited items to school. After the recognition process, once the Lambda have captured any of the targeted image, the SNS service will be active and a notification will be sent to the lecturer. At the same time, the Lambda will send the image to the DynamoDB for storing. At any time, the lecturer can always get the report from the DynamoDB in the form of table, which record all the history of the captured image. Before a lecturer need to access to the DynamoDB, it requires to access to the connector, which requires the user authentication. The connector is used to configure the access to the DynamoDB. In the connector, the lecturer can also add, delete, and edit the user rights.
I am Yongsun. Today I'm going to demonstrate how to connect the camera device to the AWS IoT core. First, we need to create an IoT thing called camera device. For this camera device, we created a smart class policy and it is set to be allow all. After that, we use Visual Studio Code to publish the camera device to AWS IoT core. In this code, we copied the Amazon root CA file and a certificate cert and a private key and a public key of the camera device in order to connect the device with the AWS IoT core. Now, the private key file name will be copied into the key path and the certificate file name will be copied into the cert path and the root CA file name will be copied into the CF path. In order to find the endpoint of the device, we need to go back to the AWS IoT core to copy the device data endpoint. After this, we will run the node IoT core.js to publish and subscribe on the IoT core. When this message connect is showed, we will go back to the AWS IoT core of MQTT test client. We need to subscribe to a topic called camera device, and the subscription will show here. We also will publish the topic, and this default message is used. After that, we publish this topic. We will go back to the subscribe to a topic to check if there is a message. There will be also a message in the Visual Studio Code. If this message is here, it means that the camera device is connected to the AWS IoT core.
Good day everyone. Amazon S3 is a data storage to store the data. So in our system, Amazon S3 is used to store the data image that captured from the camera device. And in our system, we have created a bucket that to store this image. So here is several images that stored inside the bucket that we created. So here is the sample of the first image, and we can click the link here to see the image as well. So it's a handphone, and we'll see the several images that have been stored. It's also a handphone again. So I move to this image 7, which is click on the link. It is a dinosaur. It's a dinosaur toys. And from that said, we will set the permission of this image to be accessible by public, which is over here. This is also to enable the access later on when we're using the Lambda to access this image for further process. And that's all from my part. Thank you.
Now I will demo for the SMS service in our system. After you log into Amazon SNS, you click on the topic and select the name. For our case is recognition, and then we can see all the subscription they have created inside here. And now I will click the subscription. This one will be the email. So it shows our subscription have get successfully. However, here is still something to be confirmed. The status shown in here is pending confirmation, so we need to go to the Gmail to confirm our subscription. Once it shows our subscription is confirmed, so we can go back to our topic and we can see here our new subscription has been created successfully and the status is confirmed. Once the subscription they have created in here, the user can either edit or select to delete. And all the subscriptions here will receive the notification. Now I will demo about the DynamoDB. The user can click on the table and select the corresponding table name. For our case, it's classroom monitoring, and click on the Explore Table Items. As we can see, there we have three items at here, which is date, detected item, and image URL. The date will represent about the report they generate once the image have captured. The image URL will be the image of the detected item. For here, I will show one of the example of the image URL. As we can show here, the image is the phone. That's all from me. Thank you.
Hello everyone, my name is Kaisen and I'm going to start the demo for the cognito and the lambda function. So our cognito is basically used for the user to log into the system to access the DynamoDB, which is storing the result as a table. So let's check on our user pool for Smart Classroom Monitoring. We actually create 4 users for our teammates, including me, to have a user here. So let's check on the app client setting. The app client setting, the callback URL here will actually link to the DynamoDB page, homepage. So let's test it by using the launch hoster URL UI to see we can sign in. So we sign in as a different user. We try to sign in. So if not mistaken, it will be direct to the DynamoDB homepage. Yes, this is our DynamoDB homepage. So the cognito has successfully implemented. So let's check on our lambda function, which is our recognition lambda function. It will be triggered. This function will be triggered once there's a S3. It's a S3 bucket, triggered by an S3 bucket. Once there's a new image uploaded to the S3 here, which is our bucket Smart Classroom Monitoring. So let's check the code here. We have a detect labels function, which the recognition will detect once there's an image from a S3 bucket, and it will detect the image of recognition by maximum 3 labels, and the minimum confidence will be 80%. So the try function here will try to detect the labels and store in the response here, and using the for loop to print out all the labels, detector labels, and send to the notification as an SMS to the email, and it will finally store the results into the DynamoDB that we just created. Yep. So let's try to test this function by upload an image as an example to this S3 bucket. So for this example, we will be testing by using the image form, which is a knife image. So if not mistaken, it will be detect this as a knife, then it's also a weapon. So upload succeeded. Let's check on our email. Yes, receive an email from recognition. It is detected as a knife and as a 99% confidence. As a weapon, also 99%, and also blade 99%, which the system has recognized this image as a knife, weapon, blade successfully. So not just the lecturer but also administrator will also receive this, as just depends on the setting on the SNS. So let's check on DynamoDB, see whether the image result has been stored in the table here. Explore table items. So we can see this actually has been stored successfully as a knife. Here the result that we just received, and also provided the image URL. We can just copy and paste this. Yeah, this is the knife image that we just uploaded. So this is our function as a recognized system for this whole purpose system, which is the smart classroom monitoring system. And that's all for our presentation today. Thank you.